So we read chapter 4 about efficient workflow. It was a pretty quick chapter, and I think relatively straightforward. I feel like most of this was kind of high-level conceptual planning type suggestions, but I think some things that can be really useful in terms of making a project substantially more efficient. I made some really quick slides. Let me see if I can get this to share. That looks right. You see the slides? Hopefully. Perfect. No? I
don't quite see them yet. It says that you started. Okay, there it goes.
Okay, just moving slowly. Cool. So so basically this chapter, some basic learning objectives is was aimed at helping develop a workflow that's going to be more efficient, starting from an idea of having a sketch of what the workflow should look like before you even open up the coding. They talked a little bit about different software tools, both inside and outside of R, that I thought could be useful to discuss. In particular, I hadn't seen the R libraries that they talk about for doing the kind of R internal planning, and didn't have a time to play with them, but would be really interested if other people have toyed with those, if they're any good. Talked a bunch about dividing work into chunks, and then had a little bit to say about kind of documentation and reproducibility as kind of critical aspects of an efficient workflow. So they broke it down into kind of 5 tips, and then kind of stepped through each of them that really mirror what those learning objectives are saying. So starting with pen and paper to sketch an overall workflow, making a plan for how to get things done, including dividing the project into chunks of things that need to get done. They really emphasize this idea of selecting packages really early. So rather than starting programming and then figuring out what you need, to say, let's figure out what you need before you've even started coding. Documentation, and then reproducibility, where they were really emphasizing knitr as a useful tool for that. They also emphasize that these tips apply kind of across different project scopes. So whether it's kind of a single project data analysis or a much larger scale kind of developing a tool, they have a lot of the same steps, but they may be applied in really different ways. Right? So if you're doing something purely internally to build just like a single data analysis, you may not feel the need to have as thorough reproducibility or documentation, but that there's still aspects of that that are critical. So I kind of just stepped through each of these. So that first one, I think, is something that's really easy to skip, that I definitely have been guilty of skipping many times in my own work. But this is the idea that before you get to coding, to actually sketch out what needs to get done outside of the code. Their quote for this is that smart preparation minimizes work, which I think is probably pretty accurate, but also something that's easy to overlook, because it's easy to say, okay, I'm just going to get in there and start playing with data or putting together a script. And so a lot of this is this idea of understanding what the actual scope of a project is, so you can lay things out to figure out kind of what is likely to be entailed as a project comes as the workflow moves forward, knowing who's going to be involved, what that division labor might look like. They introduced this concept of technical debt that I hadn't heard that term before, but I really love it, which is the idea that if we don't kind of plan ahead, it's easy to kind of say, okay, this code right now is sloppy and potentially not doing quite what we want it to do, but we'll come back and fix it later. I know in my own work, I like to refer to that as future Keith problems. And future Keith is often really, really mad at past Keith, because later on I get there and realize that I've now made the problem much worse by compounding the rest of my code on the thing that's broken at the outset. I remember I had this one moment when I was in grad school. I built some like really just massive mess of code in MATLAB to do a project. And like years later, I went back and found notes to future Keith that were just like, this really doesn't work well. It's inefficient. You should fix this. I'm just like, well, thanks, Passkey. Now I don't remember what I was trying to fix. And so a lot of this is this idea of saying, rather than trying to kind of go gung-ho full bore ahead to get to the end of the project, to say, let's take a breath before we start and identify what the problems are going to be so that we can approach them more proactively. This can also be useful in terms of just identifying what the kind of initial tools that are going to be needed are, right? So are there useful project management tools that we might need? And then which of these should I bring on board? And then also figuring out timescales. So yeah, I thought, yeah, pretty straightforward suggestions that I personally always ignore and then always get mad at myself for having ignored. Second step was this idea of chunking the work, which is basically saying, just rather than just saying, okay, I have a project, to say, what are the kind of discrete components of that project? And then how am I going to get those done? And you can do this kind of at different levels of granularity. I think, again, this depends on the scope of the project. That in some cases it's saying, right, you might be able to do this really kind of high level. There's a planning stage, there's a programming stage, there's a write-up stage. But often if it's anything beyond a really small project, each of these is going to be a bunch of sub-stages, and they may interact a lot, right? So during that planning stage, I know in a lot of my work, when I have messier, bigger data sets, part of that planning stage is doing some programming just to get a grasp of where the mess in the data is, right? I think data wrangling and planning are often critically intertwined, but just to say, let's break down what these steps are going to look like, and then have some idea of what the timeline for each of them needs to look like, right? So if I want to get to an end state of a write-up by a due date, to know when should I be moving from that planning to programming stage. They also emphasize potentially doing this with like the SMART framework.
By the way, if you refresh the bullets will be fixed.
Oh, did I? Yeah, perfect.
There we go.
Thank you.
You're welcome.
Sorry, I haven't actually used. Is this book down that's doing this, or?
Yeah, which
Okay,
is a flavor of our Markdown. But yeah.
Perfect. Yeah. So I've only been using R Markdown for like the last 4 months, so I'm very novice to a lot of this. I definitely have done a much more like messy, find my own way to do code, and in part in this book club in order to get more efficient with that.
Don't worry about it. Last week I did something. I've been using R Markdown for like 4 years, and I messed up my bullet points too. So
that's
thanks.
Yes. Fixing Gus's is exactly why I like immediately knew what was wrong with yours.
Yeah, thanks, Gus. You laid the groundwork for me, and I appreciate it. So yeah, they emphasize kind of chunking in these kind of SMART goal type approaches, which I thought was a good way to think about it, which is to say, rather than say, I have a chunk that's called programming, which is this, amorphous blob of, countless number of different subtasks, to say, let's identify our tasks in ways that are tractable, right? So the SMART framework is that each goal should be specific, measurable, attainable, realistic, and time-bound, right? So basically, it's something that I can say, not just write some code, but say, do the coding that does this particular task. So be specific, and then say, what is the kind of measurable outcome of succeeding at that? Should be attainable, so it shouldn't be write universally applicable code, but to say the code that's going to accomplish this task for this project. Realistic, and then time bound, that they basically is something that can be done and can be done within a reasonable amount of time. And I think that's has been shown to be an effective tool for putting things together for like planning work goals. I know my organization, we have to submit SMART goals every year to say, here's the specific, measurable, attainable, realistic, time-bound goals that I'm going to accomplish this year. And so it's clearly an effective framework with which to approach these things. So they mentioned a variety of R packages that can help with this. So the three they mentioned are Plan, Plotrix, and Diagrammer. And I think that they said this figure was made in Diagrammer. I haven't ever used any of our internal ones. So I've used kind of Jira and Trello positions I've been in, so they're external project management tools. But it's kind of cool to consider using our internal ones. I don't know if anyone else has used them.
Yes, I have used Diagrammer for my planning, showing a research project for the planning. Yeah.
And I've used Diagrammer for not for the waterfall chart, but for other presentations and all. I think the last one was part of the EfficientR chapter that I covered, and the first one I think I ever used Diagrammer was in my Mastering Shiny Book Club presentation that I was doing.
Nice.
But most of the time for presentations, yeah.
That's awesome. So yeah, seems like the Diagrammer seems to be the kind of the most optimal of these tools, or the most widely used at least. So that could be a useful tool moving forward for lots of these kind of project management kinds of things. It makes a slick little figure too.
I just wanted to add, so I recently found out about an online version of this. So Diagrammer package mainly runs over two web tools. So one of them is Mermaid, other one I can't recall, but for Mermaid, if you have to make flow diagrams kind of thing, there is an online portal, and I can share that link later. But that allows you to, like write what you would write in your R code and then create it. And so it's basically real time. On the left hand side, you write your nodes, and then right hand side, it will show you how it should look like. And then you can just simply copy paste it instead of having to, sort of add every piece and run your code and check if it is looking right. I think I found that tool really useful.
Nice.
I think it's called mermaid.live maybe, but I'll double check.
So when you're doing that, is it are there effective ways for like collaborators to also operate with the chart, or is it that you're kind of building the chart and you can share it? But
I'm not sure about the collaboration piece, but yeah, if you have made an online chart, I think it's easy for you to just share the link and they should be able to see, what you're talking about, and without having to save stuff like that. I think, yeah.
Gotcha. Cool. So the next kind of big high-level tip they talked about was package selection. They had the quote at the beginning of the book that R is notorious for allowing users to solve problems in many ways, which, as we've already talked about in previous sessions, is both a blessing and a curse, right? So it makes it so we have lots of flexibility, but also means that there's kind of a lot of degrees of freedom in terms of figuring out how to solve something. And so they talk about a situation of basically having a problem to solve where you can build kind of complex code to do these, I think they were Halverson distances, to compute the distance between 2 points in the globe across the curvature. But then said, well, rather than having to write this full code that computes all this, we also can find a package that has already done it. In a lot of cases, specific problems where you're trying to solve, someone else has already solved. And so there's no need to reinvent the wheel, because we can potentially go and find a package or library of someone that already has a useful solution to this. And so what they were really emphasizing here was doing this selection process really early. So to say, here's what I'm going to have to solve, and let's find the tools that I'm going to need to solve that at the outset, so that you're not doing a lot of kind of rejiggering your data frames to fit the package downstream. If you say, okay, I know I'm going to be working in the tidyverse the whole way through, to say, I can prep things to always be within that general framework. And so just kind of knowing where you're heading. They talked a lot about different ways that we can go about finding packages. This is something that I found a little unsatisfying in the chapter, because I felt like it made me even less confident in my ability to find the right packages, because they're like, look, here's 12 different ways to do it. and they found like 12 different answers to their question of what the right package is to do something. I know in the past, for me, it's been super haphazard. It's been, I've Googled something, whatever happened to be most digestible on Stack Overflow became the package that I used. And then often, months later, I'd realize, oh, there's a much better tool for this, or that package is deprecated and there's a better one out there. And so I guess an open question that I thought might be worth the discussion is, how do people choose the right packages? And if anyone has an idea for a way to do this kind of in a more principled way, then hope that Stack Overflow sends you the right direction.
I'm gonna dust off my DevOps for Data Science Book Club hat, because this is actually pretty much what we talked about last Saturday to some degree, that depending on what you're doing, you need to make sure that the package licenses play nice with the work you're doing. Because if you use a package with a license that says you have to share the code you write that uses it, and you're working on top secret government stuff, you might have a little bit of a problem. The other one was security and making sure that the package is doing what you think it's doing with your data and not sending it to someone else or doing anything crazy. And then the third one was like expected maintenance and package longevity. So is this some random one-off package that someone made as like their graduate thesis? Or is it something backed by a large company that we can expect to get continuous updates throughout the years?
So what are the the best ways to identify those?
So just to add on the last point, I think what it really boils down to is there an active, so is there a maintainer of that package who's actively working on it? So you would see that there are latest changes, latest commits happening in past few months, past few weeks is even better. And another way that I have seen or come across people doing it is that I think, you could think of it as, stars or reviews of how many downloads a package has had. So if you have to choose from among maybe, let's say, 3 packages that could potentially fit in your, workflow, you would probably want to look at the one that has been most downloaded or, which has highest downloads rather than other one, because then you would A, find more help on Stack Overflow, B, it's probably a better served package, or it is able to cater to more people's needs at this point. So that is at least in terms of candidate, it's a better one to start with.
I think to actually get down to how do you find these packages that meet these requirements. I've recently started using CRAN task views, which if you're not familiar, it's like, I need to do time series modeling. So you search CRAN task view time series, and then it gives you a whole list of packages that do time series and all these different specific things. But then also, like Priyanka said, if you're digging into people's GitHub repositories, sometimes people will write, I built this because I needed to do X, Y, and Z that this other package couldn't do. And then you go to that source package, and then there's someone else who's forked it and said, I did this because I need it to do this other thing that those other 2 versions do. And you can sort of scope it out that way.
Yeah, I definitely check the GitHub of anything that I'm thinking about using, or check the source, I guess. Sometimes it's not GitHub, but most of the times it's GitHub. And so it's the fine line, because it doesn't necessarily have to have been updated recently, because, if it works, depending what it's doing, it might not need updates. But I've definitely seen ones where I'm like, okay, this looks great. And then you notice that there's an open pull request that was opened 4 years ago that, hey, I fixed this bug. Do you want to merge it? And, oh, okay, no. So that's a sign that it's actually broken and is not being actively developed.
Yeah, no, I feel like, I definitely have had a really lazy approach to, to choosing packages in a lot of cases, right? Because, thinking through some of these, it feels like there's some really critical decision points. And part of it's that I think I haven't used a lot of packages that, it hasn't mattered in a lot of cases because I've mostly used R for data wrangling and then basic analysis. But I think as you get into kind of deeper analyses and right, if you're doing time series, you need to understand what the kind of underlying assumptions in the models are going to be, and that can vary from package to package. And yeah, that I think that then it seems to get substantially more important to choose the right packages. Yeah. Cool. The next suggestion is document throughout. This one to me felt kind of like the most straightforward and like the least that there's kind of needed to be elaborated on, which is you want to keep your code well commented, both for collaborators, but also for yourself, right? So I think, everyone has gotten to that point of they went back to their own code that they hadn't looked at in weeks or months or years and realized they had no idea what they were doing. And so leaving kind of meaningful comments. For me, part of this is also just naming variables in ways that make sense. So not calling things X and XX and XXX because I was trying to rush through a project. They emphasized things like Markdown as being really helpful for this. And then talked about the options to control what gets output through like the eval and echo code chunk options, to kind of use that as part of your documentation process, which I think are useful to say basically what's going to get spit out into the actual Markdown document. And then the final tip was on publishing, with an emphasis on reproducibility, which I think is something that R is kind of uniquely great at, right? That having things like R Markdown make it so that dynamic document preparation is really straightforward and really effective. Right? So they emphasize limiting the need to manually copy things. So rather than have to make a figure and then paste it into a Word document, and then later on, if you change your data, have to remember to go back and update everything to say, if everything's embedded in a reproducible document, then it's much easier to say data changes, everything automatically is updated. Within here, they talked about caching code chunks. I know we talked a little bit about caching variables last week. It's the same premise, just within a Markdown to say, rather than rerunning every code chunk every time, if there's things that are particularly time consuming, like loading huge data sets, things like that, that don't need to be redone every time you are knitting your code, you can cache those chunks, which I think is really helpful. And then finally, they talked about treating a project as development of an R package, which I thought was kind of an interesting concept. I've never developed an R package, so it was a new way of thinking about it for me. But I think, saying basically it's kind of taking the project's level of R to an even bigger level to say that you have to think about this as a useful self-contained set of scripts and tools. So yeah, that was kind of it. Like I said, it was a pretty quick chapter. I think a lot of it was kind of things that we can all say, yep, we should do that. And whether we do or not is hit or miss. But yeah, so I don't know if people have other thoughts or things that they want to elaborate on.
Does anyone use the targets package? I have seen some demonstrations of it, but I've never used it myself. It is the caching part, which reminds me of it because it is able to track what should be recalculated and what not, which is very powerful because if you cache, you need to cache manually or program that manually. It is much more difficult to decide when it needs to be recalculated or not.
Orto provides a built-in caching and freezing mechanism for like entire projects as well, which is
true.
Really handy.
I just used targets for the first time someone else had set it up. It's been on my list of like obviously useful, but it's got a little bit of a like transition cost. But yeah, it's a good point about Quarto. I don't know how much targets will kind of, or Quarto kind of takes over from some of what Target does.
You can do it on a per chunk basis as well, I believe.
Yeah.
I know that for most of what I do, I set it up for the entire project.
So the nice thing about targets is basically you like define the variables that you're using as using targets to kind of mark the variables, and then it keeps track of what variables are used in each thing. So this variable down here uses these two variables up here. So if one of these changes, you have to recalculate the one down here, but you don't have to recalculate the things in between. That kind of thing. And so it's, you know, really nice if you have especially really long running processes. It doesn't rerun the long things if the things they depend on hasn't changed or haven't changed. So yeah, it's probably like Quarto probably only covers the most basic cases, I guess, but it was still it's interesting.
I think it's more of just like the context you're using it in. Are you knitting the
Yeah.
document, or are you doing like active development with it?
Right.
Whereas like knitting with the project, so like I put all of my Advent of Code solutions on the Quarto website. There's God only knows how many things that are programmed in like the slowest way I could. And so if I had to reknit everything the whole time, it would be excruciating. But if I'm actively developing something with that takes a while to calculate, then I can use targets. And then once it's done, then it gets punted over to Quarto so that next time I knit it, I don't have to do it again.
What will be the difference in using a targets package and putting cache is equal to true in code chunks options?
The difference is that the code chunk is like the whole chunk at a time versus the target can be more subdivided. So it could be, did something change within this code chunk? Or something that this code chunk depends on. I guess the depends on piece does it. I don't know. I don't know exactly, because like I said, I haven't like I used targets that someone else set up, and so it worked really well for that. But yeah, I can't spell it out.
I have used cache is equal to true in some of the code chunks, but when I change some variables in that code chunk, and then I put cache is equal to false, it doesn't update the report, PDF report. So it's kind of confusing for me, like where we should put and where we should not. I know the Quarto has a option in the YAML header to put cache something. I don't know about R Markdown, but in R Markdown, what I do is I put cache is equal to in the code chunk options rather putting in the YAML header.
So in R Markdown, you have it in as part of code chunks.
Yeah.
For cache is equal to true, and yeah, I think it's the same option we're talking about. So I've used it in R Markdown before.
Hey, Kat, I have a small question related to your presentation. You were saying that there are many options. They were saying that these are the options available to find a package. So can you share some more detail for that? Like what options they are saying? If
Yeah,
you know.
sure. I'm trying to remember all the ones they listed. But basically they talk about a bunch of different tools, or basic places to search, right? So there's like this the rpackage.org website apparently has a search function. And so, or there's a package search package, right? So within R, you can download this package apparently, and then look for things in there. And so each of these cases, it seems that it's the idea of you're identifying keywords to look for, right? So it makes a lot of sense in their case of this haver-seen distance, where it seems to be a really specific thing to look for. And they said there's different ways, basically different places to do this. Our documentation.org has a search function. And then they had ways to look at this through, like looking at it through Crayon or through their GitHub, right? There's different places you can go to look at kind of what the update history and management of that project looks like. And so, yeah, I mean, I think in the chapter, they have these different suggestions. Personally, that I've kind of done Wild West approach of like, find what I can find, and then hopefully it works. Or, in a best case scenario, find someone that I think is more of an expert than I am in this topic, and then ask what they use. But I think, there is this kind of massive proliferation of packages at this point that can be a little daunting and overwhelming. And I think in some cases can be a challenge, right? Like if you're in like a biostats world like I am, the assumptions underlying the analysis in different packages may be different, and it may not be something that I know exactly how they implement maximum likelihood in one package versus another, and maybe kind of beyond my scope to be able to assess that. And so that was kind of where I was getting, I think that's a stressful aspect of R for me. It's one of the few times where I see why people like things like SAS or Stata, where there's kind of a central selection process. Yeah.
Thinking about ways to find packages, I have had decent success with just like, I'll Google something, I won't find the result I want, and I'll just rephrase my search and just like keep on iterating over different ways to phrase it. And invariably something comes up, and then you see how they phrased it, and then you try searching what they said, and it all goes out. And then like, I won't be kind to future me, like you said, Keith, you need to be kind to future you, but a few months down the road, I'll be like, oh yeah, what was that one specific thing I searched that turned up the result I wanted on like the third entry? But it's a pretty decent way, and I've had some success with it. So
I guess the other aspect of that kind of relates to that, Gus, is the idea of knowing when you should bother looking for a package, right? So in this case, right, they're looking for these haver-seen distances. And I guess you kind of have to know that that's something that's widespread enough that there may be packages. And so that's kind of an interesting, like, at what point is it going to be more work for you to find that package by doing 3 pages of sifting through Google results versus just hard coding it yourself?
there was one, I took over some legacy code recently, and there was this one function we were using that was like 2,400 lines long. It's absolutely massive. Like looking at it, you have no clue what's going on, but like it was getting the job done. And so at that point, I was like, okay, well, it hasn't been updated in a long time. I need to figure out what to do. And I was able to distill down just the parts that I needed to keep. And so like if I'm trying to figure out some distance function and I'm like, oh, I don't know if I need a package for this, then I search around, I see, okay, implementing it actually isn't that complicated. Here's how I can implement it based on what I see to suit my needs specifically. And then you know what's going on, you know it's relatively maintainable, and hopefully you've learned something new. And then you also avoid, John and I talked about this on Saturday, there was an old NPM package that just reversed a string. And the guy who wrote it got into a whole fight with NPM and then took it off of NPM, and like a giant chunk of the internet broke because it was some random upstream dependency for a massive amount of other NPM packages. And so like, sure, you could do it, but I could also look it up and go, oh wait, this is actually kind of easy to do on my own. And then we solve some problems.
I actually remember I was doing a micro data analysis, and in the package there was a function, and they were using the stop function to stop the analysis if you do not have a file. So what I did, I went to that function, I changed stop to print, and what analysis I wanted was after the stop. So that's another way to do like cheeky things with the packages as well if you want.
I think it's always a good thing if you find better ways or better applications than the current state of function in the package to make an issue, for example, in the GitHub repository to propose the change, for example. So because then other users can profit from it as well. If at least you think it is more generally useful. Another thing that I noticed from the book with the Haverstein example is that the number of packages returned by Metacron, and so by the package search function, is much more limited, and perhaps it's a good selection compared to the R-site search function, which returns a lot more functions and packages. Yeah, but I didn't judge. I'm not sure if you have any experience with that or the difference between both.
I can't remember which is which, but I know that one of the search package search tools has been broken for a long time, and they just recently fixed it, but it uses cached data, so it's possible that it's fixed but not totally fixed. I haven't been able to dig in yet, or I haven't taken the time to dig in and see exactly what that was, but I was watching an issue of it. Like if you ran the examples in the code, they did not return what it said it was going to return. I'm like, I don't think this is really, or I think this is broken. So anyway. All right. Well, thank you very much, Keith, for taking us through. This chapter was really funny timing because I'm on a project where I have been in kind of an exploration, getting to know the data phase, and now I'm actually building some stuff. And I was like, man, I really need to like break this work down and sort out what I need to do. And then I read this chapter. I was like, oh yeah, I need to do this.
It's timely.
Yep. So very nice. All right. Well, I will see everyone on Slack.
Thanks, everyone.
Bye.
Bye.